Murmur, I like this. Absolutely. You can expect, not only will I ask you to find the acceleration when you're on a slanty ramp, once you have the acceleration, I'll ask you to do something with it. Find a V final, find a V initial, find a time, find a distance. So, consider a 6 kilogram mass sliding up a rough ramp. Now, I always have students that say, hey, Mr. Dueck, how can something slide up a ramp? So let me pause the video and I'll show you. So we have a 6 kilogram mass sliding up a rough friction, mu 0.1, 32 degree ramp with an initial speed of 20 meters per second. Find that. Okay, you know what? I'm going to dulp, and I think I'm going to dulp right here. I kind of have some room. And here's my block. A wants me to find the force of friction. Yeah, I can handle that. B wants me to find the acceleration. I can handle that. C says find the time to stop. Yeah, I guess if I know the acceleration. Oh, stop, I know V final. Oh, they gave me V initial. Yeah, I can find time. And D says find how far. I'll find D. D says find D. If I planned that, that would be clever. I don't think I did, but I'll take that. Okay. There's my diagram. Oh, and 32 degrees. What are the forces acting on this block? Get the obvious one. Remember I told you as a good rule of thumb, always put the mg on the same side as the theta, at the angle, as the pointy part of the ramp. What else? Normal force. What else? What, Miller? Why going down the ramp? All the other diagrams we did, it was up the ramp. Last question we did here, it was up the ramp. Why? Because it's sliding. Okay, so friction is going to be this way. There's my free body diagram. If I had asked you to simply draw the free body diagram, then I would look for that, that, and that. But I didn't say draw the free body diagram. I said find the force of friction. Before I do that, what should I do with mg? mg perpendicular and mg parallel. Okay. Oh, and I tend to put the, because this is complicated enough, I tend to put the right angle there, just, Jeff, so I don't do something really sloppy with my trig. Helps me remember that mg is the hypotenuse. Darian, what's the first thing it wants me to find? Force of friction. Friction is, oh, hang on. Alon, friction is what times what? Let's write that down. Rats, I don't know the normal force. Oh, but look, 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 look. I know another force the same size as the normal force. And yeah, Jacob, I started the look, look, look in Physics 11 knowing that this question was coming. It's why I do the stupid little... What is the same size as the normal force? mg perpendicular. Mu mg perpendicular. Which is going to be mg, which trig function? I forget. I forget. I can derive it. And again, I gave you dumb ways to remember it, but if you blank, hey, adjacent it's cos, right? It's going to be mu mg cos. I'll put a theta there. Now I'll plug in numbers. Mu 0.1 m 6 G 9.8 cos 32 0.1 times 6 times 9.8 cos 32. Do you get 4.96? You know what? 4.99? If I go to 3 sig figs. 4.99 what? Newton's force. Okay. B. B. What's B asking me to find? Acceleration. Who's winning? Which way is this block accelerating? What direction, which way is this block accelerating? What?
Down.
Up the ramp or down the ramp? Boy, Dueck, are you pulling out the whole baseball going up, accelerating down shtick again, but this time slanty? Yeah! Even though it's moving up the ramp. And Kai, I'm glad your first guess was up the ramp. It's a good mistake to make. Yes, it's moving up the ramp, but is it slowing down? So which way is it accelerating? Down the ramp. So what's our winning direction?
Down.
And I gotta be fussy. Down the ramp, because when you say down, I'm worried you're thinking MG still. Down the ramp. So what's our winning direction? Down the ramp. Who's winning? Friction and? Yeah. Most common mistake I see on this question is kids go like this. They go, oh, winner. And then they go minus loser. Friction's not a loser this time. If we were sliding down the ramp, which way would friction be? Up the ramp, and then it would be a loser. But in this case, it's winner plus winner. Who's losing? It's a trick question. No one. And by the way, that's why when I did the little demo here, it slows down so quickly going up the ramp because two forces are slowing it down. Gravity, Jeff, is slowing it down, and friction is slowing it down. Equals what? MA. Now, I know I just calculated friction to be 4.99, but I'm going to gamble. I'm going to do this algebraically, hoping that maybe the masses cancel again and I get the A by itself just by filling it out. So let's see. mg parallel. What was mg parallel? Trig function. Oh, mg two lines is okay. Okay, so Jordan, I can go like this. mg sine theta plus, and right above here we wrote that friction was also equal to mu mg cos theta. That equals MA. Hey Riley, does the mass cancel? Is there a mass in the first term? Is there a mass in the second term? Is there a mass in the third term? Or the short, is there a mass in every single term? Well then, hey. That's why even though it might have been a shortcut to put in the 4.99, actually it wasn't. It's going to be easier to just recrunch it. Because what was I trying to find in part B, Jeff? And by canceling out the M's, did I get the A by itself automatically? Oh, that's kind of cool. By the way, what this is also telling you is whether this mass was 100 kilograms or 5 kilograms, it's going to stop in the same distance. Or what this is also telling you, if you were going down, so on the previous question, you may recall the masses canceled. On the previous question, you may have noticed the masses canceled. This is a nice one here. This is people skiing down a hill. The fact that the mass cancels, Jordan, that explains why a little kid can ski with a grown-up, and the grown-up isn't have to constantly adjusting their speed all the time. Or the little kid isn't having to constantly adjust their speed all the time. The fact that the masses cancel is why a little kid can hold hands with mommy and daddy on a ski hill. Otherwise, the little kid would be left behind, the daddy would be going way faster because he's heavier. Doesn't happen. It may because of skiing ability, but that's a whole different area. Okay. I guess A is going to be G. I can know that. 9.8 sine 32 plus mu. I know that. 9.8 cos 32. What's the highest my answer can possibly be? If it's bigger than 9.8, I've screwed up because then I'm in more than free fall. And I'm not, I'm looking at this angle, I'm expecting something far less than that, right? Oops, I forgot to close off a bracket. That was sloppy. 9.8 sine 32 plus 0.1, 9.8 cos 32. You get 6.02, blah, 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 6.02 meters per second squared. C. Anthony, what's C want me to find? Time, T, equals question. Okay, as soon as I wrote that, now I'm back in kinematics in Unit 1. I'm thinking VF equals VI plus D equals VI plus VF squared equals VS. Okay, what else do I know? Oh, VF equals 0. Please tell me they told me VI in the question. Did they? Did they?
Yeah.
What was VI? 20? What else do I know? What's the acceleration? Ah, did you hear him? Now we're back in the last unit. Are we slowing down or speeding up? Slowing down. So I have to now manually add the negative. I'm looking for an equation that's got T, V final, V initial, and A in it. Yep.
T equals VF minus VI over A.
Thank you for getting the T by itself already. Whoa! Screen suddenly started jumping around. And what I wrote just kind of vanished. Did it appear somewhere else? Okay, let's try this again. T equal... Whoa! Okay, little weirdness going on here. Let's do this. Try this one more time. That was like a black hole or something there, Mr. Dueck. So it's going to be 0 minus 20 all over negative 6.02. I can do that. Bracket 0 minus 20 all over negative, I'll go negative answer button. And I get 3.32 seconds. Yeah? D. What D? Oh, D was asking me to find D. Okay, the displacement. How far up the ramp will it travel? What equation can I go with here? So I can go with D equals VIT plus a half AT squared. Or I think I could also go with VF squared minus VI squared all over 2A. I might use the right-hand one just because if I got T wrong. But you know what? In the right-hand one, I'm using A no matter what. So no matter what, I'm having to use data that I've calculated, not that they gave me. So then I might lazy out and say I got the D by itself already in the VIT. So I'll probably use this one. VI 20, T 3.32 plus a half negative 0.602, 3.32 squared. 20 times answer button plus a half times negative 6.02 times answer button squared. You get 33.2. This will slide for a while. $33.2. meters. By the way, what was the force of friction? 4.99. At the top, will it come to a stop or will it start sliding back down? Well, it depends. What does it depend on? Visualize the new free body diagram. What would change direction if it was sliding down? Friction. I could fix that fairly easily if maybe I could do this in my head. So friction would be up. What's pulling it down? mg parallel. The only way it's going to slide down is if mg parallel is bigger than 4.99. Hey, what's mg parallel? That's mg2 line. You know what? I can actually do that right now. 6 times 9.8 times the sine of 32. I can tell you whether it's going to start to slide back down or not. It's, is that right, Mr. Dueck? It's going to slide back down. And friction would be pointing in the other direction at 4.99 newtons. I can find the net, I can do all sorts of stuff. So, questions I can now add from the homework. You can now do number 3, which is asking you to, A, acceleration you could already have done, but B, time to slide down. Oh, by the way, also you'll notice I've been careful. I'm using mu k if the thing is moving already. I'm using mu s if it's sitting still because there was static friction and kinetic friction, and I've told you, because I'm a nerd, I'll point that out, but I'll treat it all as one so you don't need to worry about that, right? 5 is good. Eight is good. 9 is good. Did I say 8 was good? Maybe. 12, finding an angle is cool, but I'm not going to ask you to find an angle. Well, it's kind of cool. Meh. I'll pause with that, and then we'll jump into lesson 7. Lesson 7. Nothing new. We're just going to look at some weird ones, and I'll try and tell you which ones I like along the way. Advanced inclines. Advanced inclines really is, hey, what if you got more than one mass? What if you got one mass hanging in midair and one on a ramp? What if you got masses attached with a rope on 2 different ramps with 2 different angles? We can deal with it all. We just have to be more careful and more meticulous. So here's the first one. Example 1. How much force is required to pull this mass up the frictionless ramp at a constant speed? You know what? There's a phrase that tells me an awful lot of information that I'd probably underline. What phrase might that be? Constant speed. Why, Jordan? What does that tell me? Let's make a little note here. And in this unit especially, it tells me when I go winner minus loser equals, it's going to be winner minus loser equals 0. I don't care about MA or M1 plus M2A or what, 0. Okay. Good. Suggestions? Okay, let's label our forces. What are the forces acting on this block? Get the obvious one. Good old gravity down. Is this block sinking into the ramp like quicksand? No. Is it flying into the air like Superman? No. So, yoink, some kind of a normal force pointing up. What else? What else? Oh, there's a rope. We've given that force a name before. Tension. Friction?
Frictionless.
Okay. By the way, in part B, it's going to be the same question, but I'm going to add friction. When I do add friction, which way will I point it? Down the ramp? How do you know? Because it says this thing is moving? Okay. So how much force is required? So maybe, I don't know what that rope leads. There's some kind of motor up there pulling it up the ramp, some kind of a machine, bulldozer, winch, whatever. Constant speed. Okay. I can't solve this yet. What am I going to do now? Hello. Components. So I'm going to have mg perpendicular. Again, remember, if you always draw the perpendicular first, this angle and this angle will be the same one. And then mg parallel. Right angle. Who's winning? Kai. Okay, it's a tie. Which way is it moving? Up the ramp or down the ramp? Just so we don't make a dumb mistake, let's pretend that's the winner. So we could go like, oh, which force is in the winning direction? So we could go like this. Tension, put your pencils down. Minus, who's losing? Darian, you're right. Equals, what did you say it equals, Jordan? How would, you know what? Don't write this down. Here's what I'm going to do instead. What would I do with that minus mg parallel to make it look prettier? So you know what? Pick your pencils up, and if you just want to go straight to that, I'm good with that. I'm okay with that. Now, when this question says how much force is required to pull this mass up, which force are they actually asking me to find? Tension. Okay, I've got it by itself. Great. Oh, mg parallel. Help me out. 2 lines is what? Oh, so you tell me the answer is going to be mg sine theta. It's going to be m 7, g 9.8. Okay, if we want to pull this up the ramp at a constant speed, how much force must this cable exert? I get 44.1. Double check me. Anybody else? Yep. 44.1 newtons. B. Oh. Suppose mu equals 0.65, which is pretty high. This is going to be pretty rough. This is going to be like pulling it up on gravel. How much force is required now? You know what? Let's use the same diagram. We just got to add one thing. What do we got to add? I got to be fussy, not mu. There is a mu. What force am I going to add? Which way? Okay. Now, who's winning? Tension. Who's losing? Okay, so it's going to be this. This one's a bit tougher. I'll show a bit more work. Winner minus mg parallel minus friction. But if we're at a constant speed, what does it still work out to? They want me to find the pulling force. Which of those is the pulling force? Or how would I get the T by itself? Okay, so it's a little more complicated than what we just did, but we kind of end up with something similar. We got what we originally had, and it has to overcome friction. Okay. mg parallel was mg sine theta plus Alon, friction was what times what? Boy, if you get that wrong again, okay, we're good. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. What? Sarah. mg perpendicular is right. So I can go like this. I got mg sine plus mu mg perpendicular. Now mg perpendicular, how could I break that one down? Several ways. I can remember, hey, it ain't sine, therefore it's cosine. Again, you can always go, it's adjacent it's cosine, if you forget. So, let's put it all together. Tension is going to be mg sine theta plus mu mg cos theta. What was m? 7 times 9.8. Sine, what was theta? 40 plus mu 0.65 times, yeah, nice one, Dueck. You're going to run out of room. Haha. Now I got room. Times M7 times 9.8 times the cos of 40. How big is tension now? Oh, by the way, will there be more tension or less tension with friction there? So my built-in error check is I know no matter what, the answer is bigger than 44.1, right? Haha, I'm going to be clever. Because that is 7 times 9.8 times the sine of 40 plus 0.65 times 7 times 9.8 cos 40. Do you get 78.3? Newtons. Okay. Let's kick it up a notch. Let's add more than one mass. Let's do a many-body problem with an incline. Putting everything together. Two objects. I like this question. I like this question. I like this question. Probably. Or something like this. I'm going to give you a many-body problem with a ramp. You know what? Ben, I might even consider this a little too easy. I might say, you know what? Why don't I put one hanging in midair? Or, hey, why don't I put... Do I have... I think I got one in the homework. Oh, number 3. Both of them on a ramp. That would be the upper limit in my mind. That's pretty tough. But I'd be okay with that if I made other parts of the test easier. It's all going to be the same approach. Really? Yeah. So this says two objects are connected as shown. M1 is 12 kilograms, has a coefficient of friction of 0.17. Oh, M2 sits on a frictionless surface, so I was a little nicer right here. Mu is 0. Okay. Find the acceleration. By the way, what direction must this accelerate if it's going to accelerate at all? To the left or to the right? To the right, this can pull it down and right, but there's nothing here. There's no unbalanced force to pull it left and up. So, is it possible that this won't move at all? Yeah. How would I notice that if I assume it's going to the right and I solve for A and I get a negative? Whoops, I guessed wrong. Probably doesn't move at all. So, find the forces. M1G. Normal force number 1. What else? Friction which way? What else? Oh, I'll put friction force number 1 to go with mass number 1 and normal force number 1. What else? There's a rope. What else? I think that's it. What are the forces acting on mass 2? Get the obvious one. It's going to be a normal force, number 2. Oh, tension. Tension. Who's winning? No one yet, because I can't decide because I haven't gone far enough. What you see in blue would be the free body diagram. I'm perfectly good with all 4 of those forces because they're either perpendicular or parallel to that section of the ramp. Which force am I unhappy with over here? M2G, time for components. Oh, that's the angle. That's the angle. M2G perpendicular and M2G parallel to the ramp. Who's winning? Well, first, which way do I think this is accelerating? Down the ramp and to the right. Okay. Who's winning? Whatever's down the ramp and to the right. Which is the first one that we're going to look at for that? If I was writing my equation. M2 is a mass. I need a force, Captain Obvious. Which force is winning? Jeff. Magic. So anything that ends up pointing down and right will be winner plus. And now I'm going to walk all the way along the rope. So I'm going to have winner. And then I run into tension. Winner or loser? So I want you to look over at Riley, glare at him, and say, loser. Really? That's the best you got? Riley looked a little tired. He's awake now? Riley, then we run into this tension. Winner or loser? Winner. Something you might experience in football someday. Then, common mistake, Riley. Kids want to put M1, is M1G in the same direction as the rope? Then don't be including it. What else is in the same direction as the rope that I haven't included yet? Friction, winner or loser? Have I written forces from more than one mass on the left-hand side? Well, then I better have more than one mass on the right-hand side. You having a long day, Riley?
Oh, yeah.
Yeah? Well, guess what? It just got better. You know why? Help him out, folks. Why did the day just get better? He's losing tension, baby. Oh, it's all good. It's all good. What did they want me to find in part? What were they asking me to find? Oh, how would I get... Now, I don't think the masses cancel this time. How would I get the A by itself? Divide by the bracket. So as an expression, I'm going to have A equals... Okay, it's all going to be over M1 plus M2. I have M2G parallel. That's M2G 2 lines. That's going to be M2G sine 42. And then I have minus friction. Alon, friction is what times what? I don't know the normal force. Oh, but look. I don't know the force the same side. Oh, Alon, you know what friction is this time? Mu. It is perpendicular already, right? It's this friction. Don't use this. No friction here. So you know what? I can use your shortcut from Physics 11, but remember, that's all it ever was a shortcut. It was never taught that way. So I can go mu M1G. Hey, now it's plug and chug. M2 was 12? No, 9.8. Times also, for some reason, 9.8. Sine 42 minus, what's mu? I don't know. What's mu with you? 0.17? Mass 1, 12 times 9.8 all over 12 plus 9.8. Again, these are the kinds of questions I strongly encourage you to get your calculator out right now and try typing it in. Is that right? On the top. 9.8 times 9.8 times sine 42 minus 0.17 times 12 times 9.8, close bracket, divided by bracket. That's right. Didn't get an answer bigger than 9.8, so at least it took within my guess range. I get that, I hope. 2.03? Yeah. I got Carl nodding. Carl, units. It's an acceleration. Meters per second squared. What did we just find? Speeding up or slowing down? Speeding up. By the way, Now, all the same stuff as before. If I told you VI was 0, as far as I'm concerned, I can say find VF, or find D, or find time, or all that stuff. Or if VI wasn't 0, if I just gave you the initial velocity, find V, find, all that stuff is fair game. Or I could just do part B. Find tension. Okay. Which one would be a little easier to find tension in? I think mass 1. But either would work. So we're going to look at one mass and write a one mass equation. So just looking at mass 1, who's winning? Who's losing? Equals, are we just looking at one mass, Darian? Then I'm going to put M1A. Tension is going to be M1A plus friction. It's going to be M1A plus mu times the normal force. I don't know the normal force. Oh, but look. Oh, yeah, we did this already, didn't we? Alon, we noticed it was M1G. Okay, I can do that. What was M1? 12? A is 2.03 plus 0.17 for mu. 12. 9.8. And I get, you get 44.4? I see people nodding. Before you turn the page, as a really, really nasty question, probably multiple choice, not written, could I do this whole question backwards? Could I give you the tension and the acceleration and say, hey, find the mass? I think you could get a mass by itself. And then once you know one mass, find the other mass. It is possible. You'll be seeing some of those in your homework, and you'll be seeing some of those in the big review package. I deliberately haven't gone over them. I'm always curious which of you, if I teach you something going forwards, can automatically say, yeah, I can go backwards with that. That's part of the skill I want to build in you folks. Example 2, next page. I'm going to show you the nerd clever way. But the nerd clever way really is barely any faster than guessing wrong, and fixing it on the fly. So I'm going to choose most of the time to guess wrong, and fix it on the fly. It says this: supposing you have one mass hanging over a cliff and one mass hanging down a hill. How would you determine the direction this system moves? Well, it really depends. What does it depend on? How big the masses are and what the angle is. Let's do a free body diagram. What are the forces on little m? Get the obvious one. What else? Tension. What are the forces on big M? Get the obvious one. Big mg. I guess we'd have a normal force. Tension. Hey Riley, what can you tell me would happen to the tensions if I were to write out an equation? Okay. Let's take big mg, break it up into components. There is big mg perpendicular, and there is big mg parallel. Can you see which two forces along the rope are tugging against each other? Riley, you pointed out which two cancel. So what other forces are there along the rope? Little mg and big mg is not along the rope. I got to beat that out of you. Part of it is which part? mg perpendicular is in the same direction as the rope? Okay, so let's try again, Jordan. I'm leaving Riley alone now since you're on. Jordan, which two forces are tug-of-warring at each other? Little mg straight down and? If little mg is bigger, this is going to slide uphill. Friction would point downhill. If big mg parallel is bigger, it's going to slide downhill. Friction would point uphill, and little m would get lifted up. Except mg parallel, mg2 lines, what's a better way to write that? Okay, you know what? So explain your answer. We have mg, if it's less than big mg sine O, sine, let's get the theta there, Mr. Dueck. What does that mean? Little mg goes up. Otherwise, little mg goes down. That's really the main reason I gave you that whole parallel two lines is sine. So Carl, in a pinch, you can actually just type it in on the fly, get the magnitude, type in little mg on your calculator, get the mag. Which one's bigger? Now I know the winner. I'll be honest, although that's a way to do it, I tend to just guess. How do I know if I've guessed wrong? What will I find about my acceleration? And negative, it's such a quick fix, I just reverse any frictions, which is pretty easy to do, and any winners become, and any losers become, which really just means making any plus signs into, and any minus signs into. I can do that in the fly on my equation, and I can do it by backspacing and editing on my calculator. That's actually faster than crunching this. Show you what I mean. It says, here, let's do it with numbers. For what it's worth, I'm going to guess wrong. If I wanted to find out ahead of time, I would say, okay, little mg is 5 times 9.8. Little mg is pulling down with 49 newtons. Big mg is 8 times 9.8 times sine 30. It's pulling with 39.2. So this is going to be the winner. But a lot of kids would say, how many kilograms do you see here, Darian?
5.
How many kilograms do you see here? 8. They might, oh, the 8's bigger, is going to be winner. Let's guess wrong. Anyways, first of all, let's label our forces. What are the forces acting on the 5? Get the obvious ones. M1G, tension. What are the forces acting on the big mass? M2G, normal force number 2, tension. Friction? Yeah. Which way? Let's decide, even though we're wrong, that the 8 kilogram is sliding down the hill. This is sliding down the hill. If it was sliding down the hill, which way would I point friction? Let's do that. This is wrong, but I'm going to show you with the system I'm teaching you. The nice thing is, Alon, even if you guess wrong, it's an easy fix. What we would do now with that M2G pointing straight down. So it's on a ramp. We would componentize it. We would go M2G perpendicular. We would go M2G parallel. We've decided that the 8 kilogram mass is sliding down the hill, which means who have I really decided is the winning force? Who's winning? If I've decided that things are going this way, who's winning? Okay, so let's do my equation. M2G parallel is a winner. Even though I'm wrong, it's okay. What would tension be? Winner or loser? Loser, let's put a minus tension. What would friction be? Winner or loser? Loser, let's go minus friction. What would this tension be? Follow it. It ends up being a winner. Riley just got more relaxed. Woo. What would this M1G? Follow it, follow it, follow it. It ends up pointing up the ramp, so it's going to be a loser. Have I included forces from more than one mass? Yes, you say. Well, then it's going to be still could do this. I still would say, how would I get the A by itself? Divide that whole mess by M1 plus M2. M2G parallel. What's that? M2G sine theta. I usually put a theta, and then when I actually plug in the numbers, I put in the angle, because I'm also trying to reinforce generically, algebraically, what's going on, spot patterns. Minus, Alon, friction is what times what? Mu times the normal, I don't know the normal force. Oh, but look. I know another force the same size as the normal force, what? And what is M2G perpendicular? Cos. And then I have minus M1G. I'm going to go into the tension section a little bit, and then we're going to do, I got lots of room to do tensions. So I'm going to plug in the numbers here. A equals, I've scrolled down. What was M2? 8 times 9.8 times the sine. What was the angle, Jordan? Was it 30? Even? Minus mu, is it 0.05? Was mu 0.05? Yeah, I made it really slippery. What was M2? 8. Don't forget the 9.8. Cos, what'd you say theta was, Jordan? 30. Minus, I've scrolled down. What was M1? 5? Times 9.8. All over. Hey, folks, look up. Will I lose you if I go 13? Do you mind? Can I go 5 plus 8 in my head? All right, so now I'm going to go to my calculator. Everything in the top is going to be in brackets. Bracket 8 times 9.8 times sine 30, close off the sine, minus 0.05 times 8 times 9.8 cos 30, close off the cos, minus 5 times 9.8, close off the top, try typing it in on your calculator. And I get see if you get the same. First of all, the negative would make me go, oh, I guessed wrong, but I'm kind of go, meh. And by the way, this is why it's also worth learning how to type this all in one line. Am I right? Let me double check. 8 times 9.8 sine 30 minus 0.05 times 8 times 9.8 cos 30 minus M1G. I think am I right? Double check me, but I think I'm right.
Yeah. You would be correct.
Except I know I'm wrong because of the negative. Is that okay so far? So, relax. So I would now go back to my free body diagram and I would say to myself, self, who is winning actually? M1G, which means which way is that 8 moving, up the ramp or down the ramp? So I would probably take out my pen or my pencil and I would scribble out that and I would point friction that way. I would do that. And then I would say, okay, in my system, M1G, winner or loser now? Winner. Are the tensions still going to cancel? Yeah, then friction, winner or loser? If this way is winner, friction, winner or loser? Oh, still leave it negative, because it's the loser. M2G parallel. I would domino that down here as well. Negative, leave it, positive. On my calculator, I would go, okay, negative, leave it, positive. And I get, oh, I guess the acceleration is actually 0.493 meters per second squared. Which way? Up the hill. We'll finish with part B. I have what, one more? Almost got this done. Geez, I can't quite get to the end. B. What does B want me to find? Tension. Okay. Tension. Well, in which mass is tension a winner? Mass 1, the 5, hanging, or mass 2, the 8, going up the hill? Mass 2. However, which mass is uglier and has way more yucky forces on it? Mass 1 or mass 2? I'm going to find tension using mass 1, Darian, because it's way cleaner. Even though mass 1 is a loser there, I'm going to find tension using mass 1. Okay? What would my equation be? Winner minus loser equals M1A. How would I get the T by itself? I get tension is going to be M1G minus M1A. I can deal with that. It's going to be M1, what was it, 5? Five times 9.8 minus 5 times answer button. And I get 46.5 newtons. So I like this question, I like this question, I like this question. Some kind of multi-body with at least one ramp. Heck, maybe 2 ramps. Did you get that okay? You're looking a little frowny. By the way, this is your chance to start really figuring out your calculators. Okay? Is that right? Is it 46.5?
Yes.
People nodding? If you're not, I'll help you with your calculator in a little bit.
No, you're not finished, but thank you for the walk.
Quickly, money. I'll do example 4 at the beginning of next class. Example 4 is a great example of going backwards. What are they asking me to find in example 4? And mass 2. I gave you the acceleration instead of find the acceleration. Okay, if I give you the acceleration, you should be able to find other stuff, and you can. But I'll pick up with that next class. So lots of homework, but you have a week, and it's not a long weekend tomorrow, so you can still get it done tonight. I don't like giving homework over long weekends, but I'm not really, because I don't see you for a whole stinking week. What's your homework here? Absolutely number 1. And I would consider number 1 to be a B level Physics 12 written question. Totally fair game, expect to see it. Sure, 2 is good. I'm going to assign 3, but what are they asking you to find in 3? That's the one I was going to do at the last question that I didn't get to. So if you can't get it, I'm going to say put a star next to it. That I would consider probably an A+ Physics 12 question, which means I wouldn't feel comfortable throwing that on the written. I would feel comfortable if you want, hey, what level of difficulty will the nasty multiple choice be? Ding, 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 something like that. Okay? 4 is good. I would underline at rest. The reason I added, but if pushed slightly, it will begin sliding, what I'm telling you is it's almost ready to move because I'm asking you to find the coefficient of friction. We found the coefficient of friction last day, but I said it was the minimum coefficient of friction. Here, because it's exactly ready to move, the coefficient of friction that you find will be at the coefficient of friction. Can't be any bigger because it wouldn't be ready to move then. 5, yeah. Ooh, find the value of theta. Nah. 7, 8. Water skier's cool, but no. Combine that with what I gave you from lesson 6 and this. There's your homework. Okay, folks?